Here we're going to look at a slightly more realistic problem. So what happens when we involve friction? So we looking at this question. So we're saying object starts today. It's a roller coaster. Initially has a speed of 3 meters per second. And at c it's 16 meters per second. So the question is, how much energy is lost? So what we can say is kinetic energy. So we always know energy later on must equal to energy earlier on. So KE1 plus PE1. We're going to actually add in a work term plus W. Now you can put that number, that W, on the left side of the equal sign or to the right. It doesn't matter. Some textbooks do one way, some do the other. But that represents the energy either being taken or added. So in this case, it's going to come out to be a negative number because we know that the energy later on, the KE plus PE2, must be less if we're losing stuff due to friction. Now if we go ahead and plug in the numbers, we have 1/2 times 950 kilograms. And it's traveling at 3.0 meters per second. We're going to square that. Plus our potential energy, which is 950 kilograms. Times gravity, and has that 40.0 meters height, plus W. Now that's going to equal to the right side. So we have is 1/2 times 950 kilograms times 16.0 meters per second squared plus 950 kg times G. That's 15.0 meters. So what's going to happen now if we just solve for our values? Let's just go ahead and solve for it. So we have 950 times 3 squared divided by 2 plus 950 times 40. Times 9.8. So we end up with quite a large quantity of energy, 377,055 joules of energy. And then plus that W is equal to 0.5 times 950 times 16. We have 261,392 joules. Solving for work, we get a value of negative 1.2 times 10 to the 5 joules of energy lost. That's how much energy is lost in this scenario. And we could have, instead of doing that 40 meters and that 15 meters, we could have just had 25 meters and 0. If I set this as my 0 line, the difference in height would have been 25. I just showed all the work for this one, but both would work. You can actually extend this question one more. It says, what happens if total distance from A to C is 85 meters, what average force is exerted on the car? And how we can solve for that, we know that work is equal to force times distance. So all we are going to do is take that 1.2 times 10 to the 5 joules divided by 85. And we end up with a value of force is equal to negative 1400 newtons. So basically, we have a constant friction force of 1400 newtons in this scenario.